Hey everyone, at Scalekit, we are building hot stack for AI applications. We have supported hundreds of customers for their authentication needs for the MCP servers that we are building. As part of the journey, the MCP spec itself went through multiple revisions. First, the OAuth authorization layer for MCP servers, and then the DCR, and now the CIMD. We would like to take some time to talk about our own journey of what was our experience building the authentication layer, having to support all these protocols, and what we think is good versus what is okay. What do you need to do as part of building your own MCP servers? What are the things that you need to keep in mind? We thought sharing our experiences will help you on this journey that you are going through yourself. So I have Akshay with me, one of our senior developers at Scalekit, who predominantly focused on building the authentication layer for MCP servers. Has seen through the journey over the last 6 to 9 months, he evolved our platform as the MCP spec itself has evolved. Yeah, we are glad to have Akshay here talking about his experiences and what his journey is.
Great. Thanks, Ravi. Yeah, the original MCP spec that came ahead really structured it well by dividing the entire OAuth journey into a discovery phase, into a registration phase, then the authorization phase. And specifically, if I talk about why we needed that discovery phase. Originally, when people started building MCP servers, the thought was that the MCP servers themselves will be the authorization servers. And I think a major shift happened when the spec told that the MCP server can be separate from authorization server, where it took a lot of burden away from the MCP developers so that they can use an authorization server which is well trusted in the market, keeps up with the specs, handles all the security protocols.
Yeah, I think that's a brilliant point that you brought up, Akshay. Like you said, the MCP spec itself went through its own revisions in the initial versions, November 2024. It doesn't even have anything for authentication. But then in the May revision of the spec itself, like you said, they clearly separated out, hey, there is an MCP server that acts as resource server. There is an authorization server that is responsible for identity validation and issuing tokens to the MCP clients. And then the MCP clients can use the tokens to talk to the MCP. So I think this is the first most important thing that clarified and made the job of MCP server developers that much more easier, because they can start leveraging third-party identity providers to do the identity and authentication aspects of it, and then leave the business logic problem to the MCP server developers. Yeah, I think that's a great point.
Okay, yeah. The moment that happened, the biggest challenge was because the MCP servers will be used by customers, and customers can choose to have any sort of clients which cannot be pre-registered by the developer of the MCP server because it's just not scalable. So if I want to have a better reach as an MCP developer, it would be really difficult for me to go to each of my customer and give them a separate client ID secret. And that's where the thought of how can an MCP client make itself known to the authorization server. And that's where the registration part of it started, at least on the discussions.
Yeah.
It started there.
Yeah, like for example, if I'm a developer who is building login with Google, or I want to leverage GitHub's APIs, like you said, I as a developer need to log into their dashboard, register myself, tell them what my company is, and go through a verification process. And then I would get my own client ID, client secret, which I would use to complete the authentication workflow. But like you said, the users who are using these MCP servers need not be developers. So how do you make the journey of these users as easy as possible? And that's where you're talking about the DCR, the dynamic client registration itself came into picture. I would let you tell us more about your experience of discovering the DCR spec. To be honest, I didn't know DCR existed in OAuth spec catalog at the time.
Yeah, DCR definitely helped. But then when the DCR came and about how the client registers, it still needed a discovery part of it, because the client, for example, if you're using Claude, VS Code, ChatGPT, it doesn't know where to go, where to register itself. And that's where the discovery phase came in. And so if you see how the flow would go about, the client will hit the MCP server, will respond saying, I'm a protected resource. I cannot talk to you unless you authorize yourself. And it gives the metadata on how it should dynamically register. And the MCP client would take that metadata, which is in context of DCR, is a URL called the client registration URL, and it would send a post request to the authorization server, because in this case the authorization server is doing the client registration, and while making that post request it will have all the details about the client, like the client name, the client URI, the logo URI, the redirect URLs, etc. There are a lot of other parameters that it sends. So when it makes that post request, the authorization server creates the client, persists that client, and gives the client ID and secret back to the MCP client so that it can use it for further authorization process.
Yeah, this is why it is dynamic, right? No one is registering manually, logging into the developer consoles of these products and then saying, I'm so and so, can you give me a client ID, client secret? But everything is dynamically happening. And it's all anonymous, right? From the authorization server point of view, the client is an anonymous identity because I'm assuming these client registration endpoints that you're talking about, they're not protected endpoints. Anyone can just hit that API call and register themselves as a client.
Exactly. And that's where the anonymous nature of it, that anyone can do a registration, that is what, while implementing, scared me in the beginning, because it brings in a challenge, because it's not a protected endpoint. How does an authorization server really check the authenticity of it? Random desktop app can call it VS Code and register itself as VS Code, and everyone will see it as VS Code. People did solve it in couple of ways. Those are not scalable, but good from a security point of view. Either people started managing an IP allow list, like Claude has published its IP allow list. But then I was just reading one of the emails that came from Claude that they are going to update their IP ranges. So this is going to be a breaking change probably in January of 2026 if authorization servers don't update that. Yeah, operationally it becomes difficult there. So yeah, that anonymous nature of anyone being able to call DCR is a challenge and limitation. Yeah.
Yeah, especially when I think about it from the enterprise context, this becomes a nightmare because the security teams inside large organizations don't have visibility and specific control over, hey, what these MCP clients are that their employees are giving access to their application data, maybe their customer data or their organizational data. And again, the users who are using these MCP servers may know what these clients are, but it's very hard for them to recognize a good MCP client versus a malicious MCP client, and yeah, anything can happen from there.
Agreed. Yeah. Yep. And then,
Yeah,
the other problem is the bloating of clients, because it's not like VS Code is a single client when it comes to DCR. It's every instance of ID is a separate client.
so basically what you're saying is if there are 1,000 users who are using your MCP servers, and if each user is using VS Code in their laptop, then technically there are 1,000 OAuth clients
Exactly.
that are registering with the authorization server.
And that's difficult for the MCP server developer who wants their MCP server protected, because now there is a list of thousands of clients and it's very difficult to see which one is active, which one is not active, which one is dormant, which one is acting malicious. Managing that becomes difficult.
Yeah, even from the authorization point of view, I think it's very hard to scale from the performance point of view, latency point of view. I think it breaks down at a lot of layers from security and performance and scalability and reliability point of view. Yeah, but DCR was the need of the hour at the time. It was solving a really particular pain point that end users can't register themselves as OAuth clients for them to use to authenticate their client to get access token to talk to the MCP server. So tell me more about what your experience implementing DCR as part of the Scalekit operation platform.
When we were setting up the system for dynamic client registration, we wanted to keep the enterprise aspect primary on our platform. And there the multi-tenancy came into picture, because business to business application will have multiple organizations, users spread across different organizations. And then in that multi-tenant environment, we created the API in such a way that it can support the infrastructure in the context of B2B.
Yeah, so it's great, right? Now In the latest spec of MCP, CIMD came as an alternative to DCR, which hopefully mitigates some or most of the challenges that the authorization server developers or MCP server developers are facing to support DCR as a mechanism. Again, Paul Cotton articulated really well in his blog on why CIMD helps in a lot of these scenarios. You spoke about the client bloats. You spoke about the authenticity and validity of the client themselves. So yeah, tell me more about CIMD. What was your initial reactions? Did you really think this would solve the challenges that you faced with the DCR?
Absolutely. The explosion in the number of clients that gets created with each instance. So as we were taking our earlier example, if there are 10,000 users and everyone is using VS Code, now there will be only one single client. It makes it easier for the MCP developer to manage that one single client.
Yeah.
Doesn't have to worry about so many clients.
Can you briefly explain how it works? Yeah.
So in a traditional OAuth, there is a client ID, be it dynamically registered or pre-registered, and that client ID is passed on. And that client ID is unique, of course. So with CIMD, the thought was that how about the client itself hosts client ID metadata document JSON, and this URL itself can be a client ID because it's unique enough. And when you so there are like VS Code has it, Claude has it, MCP Jam has it. So if you open that metadata JSON document of the client, it's the same information that used to come through the DCR post call, which has the client name, redirect URIs, logo, and other things. Now I can confidently tell that, hey, this came from vscode.dev or this came from mcpjam.com.
Yeah.
Or Claude.ai. So this helps in checking the authenticity apart from the other things that the authorization server does, like making sure the entire flow is IP pinned and the other aspects.
Yeah. So the way I'm thinking about this, actually, this solves the ownership problem. Now, if the client ID that's coming in is Claude.ai slash, CAMD.json or whatever, then the authorization server can verify by going to that HTTPS URL and then getting all the necessary details and then say, okay, this actually is owned by them. The biggest advantage is that metadata JSON would also have the redirect URL as part of the data, and you can match whether the redirect URL that is passed in the authorization URL matches with one of the redirect URLs configured in the metadata JSON document itself that is hosted on their domain, their website. So there's absolutely no way for someone to pretend like their Claude code or someone to pretend like their VS Code. From the enterprise security point of view, that is great. Yeah, so now what is the authorization server's role in this? Like now the client is not registering itself. It is sending an authorization URL with their client ID, metadata JSON URL as the client ID. Now, what is the role of the authorization server here? What is it doing?
In this case, it's the responsibility of the authorization server to check on the authenticity of the client, as we were talking about. Also to make sure that, let's say that there is a malicious client out there which has created like a 50 GB size of metadata JSON document just for denial of service, and many more security aspects. So it's now up to the authorization server to make sure that such malicious clients are weeded away, and then only the good compliant MCP clients using CIMD are the only ones through which the OAuth authorization server, OAuth authorization flow continues to work.
Got it. So, do you see CIMD is practically a better alternative in all of the scenarios where pre-registration of a client credentials is either not possible or not required?
I do see it as a better alternative, and to a lot of standard, like well-known MCP clients, it does fit in. Although there are still going to be MCP clients which run only on desktop, which run only on your local machine, which do not have a web component, which do not have a place to host this metadata document. They would still need DCR. So for an MCP developer, MCP server developer, it's best to support both so that they have a wider reach for their MCP servers, because if you're not sure as a developer that your customers are definitely going to be using, let's say, Claude, ChatGPT, VS Code, and if there is any other MCP client, then it's best to have both, the support for both.
So while you're speaking, what two thoughts came into my mind. From the enterprise context, now CIOs or CISOs can say, hey, allow only these client IDs that are part of the whatever cursors or cloud codes, whatever is allowed by their enterprise policies. And authorization server can simply accept this because again, they have a valid way of verifying what is the domain of these clients itself.
Exactly.
Yeah, I thought that's a brilliant advantage. One other thing that I was thinking of is today, we as an OAuth client need to register with Google separately, GitHub separately, Microsoft separately, etc., etc. What if I present my CIMD.json in my scalekit.com domain? I don't have to go to all these authorization servers out there to register myself and get my own client credentials. If they support it, my job as a client is that much more easier because I just need to host a static JSON document in my domain and then can use that everywhere.
Totally, totally. Yeah. Yeah, that definitely eases up the client developer side problem. Yeah, yeah.
Fantastic. Now, I don't know if there are a lot of authorization servers out there that support CIMD, but so what was your experience going through the spec, reading it, and then implementing it? Did you come across any challenges? Maybe any developers who want to build their own authorization server with CIMD support? What is your experience like?
Yeah, I would say specifically in CIMD, the major part is on the different sort of validations that you have to do because even though you have that URL, it just doesn't mean that we can do the authorization. So if anyone is trying to build an authorization server, I would say definitely according to the spec, go through each validation that's required because that's what we did here. Make sure that we test it exactly for all those validations that are needed so that, yeah, if there is a malicious client out there, we would never know when that would just start.
Yeah. Yeah, because it's a very easy attack vector also. Anyone can just initiate any auth authorized URL on the browser with bad malformed JSON as a client ID. And as an authorization server, you need to make sure that you have all the checks and balances in place and all the validations in place so that you don't succumb to any of these attacks. Yeah, thanks. Actually, today, Scalekit as an authorization server supports pre-registered client credentials. It supports dynamic client registration. It also supports CAMD. So if there is a developer out there who is building their own MCP server, and if they want to use Scalekit as an authorization layer for their MCP server, can you just briefly explain what their journey would look like?
Using Scalekit, it's a simple four-step process. You would come to app.scalekit.com, register your MCP server over there. You'll get a well-known auth protected resource metadata, the endpoint and the JSON. You configure that in your MCP server. And on the validation part, whenever you get a request, you can use the Scalekit's SDK to validate the token to make sure it's an authenticated request. And additionally, you can also enforce scopes. So in scenarios like where you have you want to control that I want tool number one to be only accessed by managers, tool number two
Okay.
only to be accessed by any other employee. So yeah, using these four steps, you can get your MCP auth set up within 5 minutes.
And if it is fast MCP, then I think it's just 5 lines of code.
Exactly. Or you just put it into the environment variable and it starts working. You don't have to change a single line of code there.
Got it. Hey, this is fantastic, Akshay. Thanks so much for explaining everything about CAMD and DCR and why CAMD is a more secure alternative to DCR and yeah, how Scalekit implements both of them and can support a wider range of MCP clients. MCP clients that support CAMD can use it right away in a more secure and scalable fashion. And for MCP server developers, they can add auth layer in just 5 lines of code if they're using fast MCP and in just 5 minutes, even otherwise.